So for SSC, in order to prevent SSC in our steel material, we can ask the procurement or the buyer or to the manufacturer that my steel should have a low sulfur content. Right. So in that way we can.
No. Sulfur content is for HIC. Sulfur content is for HIC.
Sulfide stress corrosion cracking SSC. It is. I think.
No. Sulfide. Sulfur, that is H2S. The sulfide is H2S, not sulfur in the steel.
Okay.
SSC means stress corrosion cracking.
No. SCC is stress corrosion cracking. SSC is sulfide stress cracking. SCC and SSC are two different mechanisms. Huh?
Yes. Sorry.
So you have to, if you have to minimize it or you have to reduce it, SSC as well as HIC in our steel material. So what precaution should we take, or we should tell to the manufacturer that my steel should have so and so thing?
Let me go one by one. Okay, when you are having a normal, the restrictions for SSC is given in ASMR 0175, which is you should not have nickel content more than 1%. You should have a hardness of base material which is 22 HRC. Hardness of weld is like 250 HV below. And if there is any cold work, you have to do a PWST. Any fiber stretch elongation greater than 5%, you have to do a PWST. Okay, no residual stress should be there like that. That's the concept. And then you have to have, you should not use free machining steel. And then you have to control the hardness. Okay, hardness control, nickel control, especially less than 1% and then you have to have, you should not use a free machining steel, and then you have to have a hardness 22 HRC, and then if you are having a weld, it should be less than 250 HV, either with PWST or without PWST, and then if there is any cold work, then you need to have a PWST. This is for sulfide stress cracking. For HIC, the requirements are like this. For plate, sulfur content is less than 0.003 weight%, seamless pipe less than 0.01 weight%, forging and casting less than 0.025 weight%. Okay, now seamless pipe, forging and casting, if the sulfur content is lower than the limit what I have mentioned now, there is no need of HIC testing. But for plates, even with less than 0.003 weight%, you have to you have to do a HIC testing.
Okay.
Yes, sir. Now sir, the question is whether HIC and SSC both always will be there, or how it is.
Okay, when it is a sour environment,
yes.
Okay,
yeah,
when it is a sour environment, all the material, any product form like plate are vulnerable to H2S corrosion and this both cracking mechanism, SSC and HIC, both are vulnerable.
Yeah.
Okay, how to prevent it? Buy the material which is compliant to NACE MR 0175, weld with the NACE certified WPS, you are eliminating SSC. Okay, you are eliminating SSC.
Yeah.
For eliminating HIC, buy the material with the sulfur content. Only for plate and welded pipe, do the HIC testing, you are eliminating HIC.
Okay. So by default, when I say sour service, means both mechanisms will present. So HIC and SSC. So we need to restrict the chemistry also, and also we need to do the testing for plates. So this is mandatory. Yeah, that is strongly recommended.
By procuring NACE material, you are eliminating SSC. By restricting sulfur and doing HIC per plate, you are eliminating HIC.
Yes, sir. Understood. Clear, sir. Clear.
Yeah. Okay, Abhishek.
Clear. Thanks, Mr. Shwanathan, sir. Thanks.
Okay. Any other query? Any other issues? Anybody? Or related to material or something, Vishwanathan?
Is there any piping engineer or stress engineer in this group?
Stress means what?
Because I want to understand the difference between the terminologies used by stress engineers. Like hydraulics, in the piping they do hydraulics, surge and stress analysis. So in order to calculate the flow rate or the velocity and to calculate the thickness. So these are the terminologies normally I hear from them to come to a size or thickness of a pipe. So I wanted to understand the difference between these three analysis.
So normally stress on that one.
Okay, I can add a few words. I don't know much, but I can add a few words based on my experience.
Yes.
The thickness
please.
calculation is based on, you know, that the equation is there in 31.3 as well as in section 8 division 1. We have the equation like stress related to thickness, that joint efficiency. That thickness is, the equation is there for the thickness calculation. For velocity, it is very simple. You have the flow rate, right? You have the flow rate which is kg per hour. Okay. And then you have the density of the fluid, which is kg per meter cube. Now, if you divide the kg per hour divided by the density of the fluid, if it is water, it is 1000. Okay, if it is any other fluid, if it is hydrocarbon, it is 800 to some 700 to 900, somewhere in between. You have to, that process engineer can give the data. So, if you have the kg per hour divided by kg per meter cube, then that results in meter cube per hour. Okay, now the meter cube per hour, you divide it by the pipe cross section area, meter square. Pipe cross section area is meter square. Meter cube per hour divided by meter square is meter per hour. And meter per hour, you can convert it into meter per second. So that comes your velocity inside the pipe.
What is the significance of calculation of velocity? Why do you calculate the velocity?
Okay. The velocity determines your erosion corrosion. The velocity, you know, the limits, they have to design always the piping under the API RP 14E, erosion and velocity limit. The velocity of a liquid is like 1 to 4 meter or 3.5 meter per second, they say in the industrial practice. That is the liquid velocity maximum it can have. And if you have like a amine which is loaded with rich amine, they still limit it to 2 meter per second, 2.5 meter per second. Still, they still limit it to that. The fluid with the high velocity will cause erosion corrosion. Okay. For gas, it is very high, like 20 meter per second or sometimes 30 meter per second. Okay. So the velocity is means decreased by your increased pipe size, or you know, it is limited by the pipe size. Okay. So velocity is very important to control the erosion corrosion, and we have to design the pipe as per API RP14E erosional velocity limit. So that's why the velocity comes into picture. It causes erosion corrosion.
Also,
Okay.
it is, I mean, it is to control, I mean, prevent any undue vibrations, because rho v square is important.
Yeah, the Reynolds number and other things are there also there. Yeah.
Yeah. I mean, momentum actually, rho v square. Mass. I mean, that's why when the density is low, your velocity is high, and when the density is high, it's inverse. So rho v square product, so that will determine. So like that.
Okay, Abhishek, you got? Okay, any other queries or issues? Anybody? Okay, Abhay sir, I think at the beginning, Ramakrishna sir is asking about the wind factors calculation in that one. Did you done anything related to that one for offshores and that one?
No, sir. For offshore services, I have not done any wind calculations. But in normal onshore, field area, we have done the wind design as well as seismic design for the pressure vessels. So
yeah, but that in wind design we done for pressure also. But did you calculate that factors and that one by yourself? That values?
Yes, sir. Especially in case of, certain projects which we have done in India, we have got IS 189-875 Part 3, which talks about the wind load design. So based on those codes, there are K1, K2, K3 factors, and there are KD, KC, and KA factors are there. These factors are already there in the code. There are certain tables depending on the terrain category of the wind exposed zone. These factors are there. So we have to select those factors from this code, and then we can calculate the wind design. We can calculate the wind pressure, and then once the wind pressure is design wind pressure is known, we can calculate the wind load on the equipment exposed area. So especially for the Indian scenario, yes, I have done.
Okay. I think Ramakrishna, you have to just follow the same thing what Abhay has told.
Actually,
just refer that code which you told API.
For IS codes, I have also done the manual calculation. But this offshore is, for this particular.
Yeah, offshore also, as he said, just refer that code. There might be some
I need to read the code.
Yeah, just they given maybe some table in that one. There's factors are available.
Yeah.
That factor
Yeah.
you have to use and you have to just calculate that.
Yes. Yeah. Thank you.
Okay, welcome.
Conclude, sir, on amine service. If it is amine service, it is dominant. Then I think we need to do the only PWST, right, sir? Vishwanathan, sir. I mean, other than
the main. It is basically okay.
Yeah.
Anyway, NACE will be applicable. Again, NACE will come. So you have to do the chemistry control, harness control, everything.
Yeah.
The main damage mechanism in amine service is amine SSC. One is amine corrosion, which is taken care by, if you don't put SS, then if you are using carbon steel, then you need to do a PWST because to mitigate the amine stress corrosion cracking. Okay, both the damages are happening. One is the SSC, that is wet stress damage is also there. Amine stress corrosion cracking is also there. Okay. So basically the PWST mitigates both, actually beneficial to mitigate both.
Yes. So PWST,
okay.
I mean, mostly it will become mandatory. So if it is amine, we can say like that.
Yeah. Only many people they use, sometimes I have seen two type of design. One is downstream of the flash drum, there will be a pump. After the pump itself, they start SS metallurgy. But some Indian clients, they go for cost. So only they will go SS only after the valve upstream of regenerator, which is the flashing, that will happen. That's a let down valve. So only from there they will go for SS. Okay. And the top regenerator will be SS cladded. So basically, these two designs I have seen. If we are going from the pump downstream of flash drum till the regenerator, everyone is SS, everything is SS. There is no need of this PWST issue.
Correct.
Okay, only because the amine SS is resistant to amine SSC. Only when you are having a carbon steel, even downstream of lean rich amine exchanger till the letdown valve, then you need to go for PWST for the wells to control the harness, to control amine SSC.
Yeah, we have an amine absorber where the bottom section is cladded and the upper section is the carbon steel. So in that case, we have to do PWST. But when it is cladded, I think it is bit we need to be careful. So, yeah.
Okay, because what happens is in the absorber, all the H2S and CO2 are absorbed by the amine. It comes in the bottom of the absorber. So that region is basically for corrosion purpose. They clad it actually.
Yeah.
But once you are cladding it, I think it's a barrier actually.
Yeah, that's what I mean. But PWST is required because of amine service. So upper part is
on a clad at a carbon steel, they are asking PWST. I mean, because once there is a cladding, there is no corrosion. There is no corrosion means there is no hydrogen ion formation. Means that is a resistant actually.
No, but it is two sections. The lower section metallurgy is different, and the higher top section is with cladding and without cladding. It is both are welded. So maybe I think then we need to do the separately, and maybe do the weld. I think.
Okay. Maybe that joint, that particular joint, where the portion is joined, that is maybe they may require PWST there. Yeah.
No, but in your upper part, I think it requires PWST because it is without cladding.
The upper part is basically actually the only sweet gas is going, but generally, the people don't take chance and they don't know where this absorption happens and where, generally that absorber, they will specify PWST for the upper part also, though it is sweet gas, but still they will, specify because they cannot guarantee that, where the amine, absorbs and then whether it will cause cracking or not. So the absorber usually they will recommend PWST.
Yeah. As per the specification in amine service, you need to do the PWST. So now, since it is two different metallurgy, so when there is a cladding with the carbon steel base metal, it is not required. But since it is a same vessel, so we need to take a decision how to do it. So that maybe we need to do the PWST for the upper part separately and then do the welding of with the bottom section. Yeah, something like that we need to do. So that part. You understood?
Basically, I understood. Basically, what happened is when they are going for the cladded one, or this one, and when they are using either austenitic filler wire or something like that in the root, they don't ask for PWST. because the part which is exposed is not undergoing any corrosion. Only if I suppose the code is asking for PWST, right? Then they will not exempt. Suppose the thickness, the code is asking like 19 mm or 38 mm, whatever, that one if it is required as per the code, it is mandatory. Then they will not exempt you.
Yeah. Actually, we have two trains. Actually, first train in that it is below the code, but the other one we were had to do it. There it is higher. That also we need to see how to do it.
As per code, if it comes, then they will not leave it. They will not leave.
Yeah.
Yeah, it will reduce that to reduce that stresses and that one after welding and that one. They want that PWST and that one.
Yes.
Okay, Ramakrishna, got your answer.
Okay. Yeah. Good.
Okay, any other points, any other queries or any other experience anybody want to share?
Yeah. I have one issue.
Yeah.
So our QC manager has raised a concern that the material shall be SSC tested, something like that he mentioned. But I think it is not necessary, unless the client specifies. We are doing HSC testing and we are complying to NACE. So complying to NACE and the sulfur restriction is enough for SSC resistance. That's what I understood, Vishnu. Sorry. My understanding is correct?
Yes, your understanding is correct. So there are list of materials given in NACE MRC 175.
Yeah.
Like basically some materials, pipe materials they have mentioned. After that they have mentioned, ASME section 9, that materials, that one they have mentioned.
Yeah. Yes.
So basically those, when you use those materials, automatically they are no need HIC, means SSC testing. If they only need to comply to the chemistry, hardness and other requirements, and then will be directly inherently resistant to SSC. The SSC testing is required only when you have different material, like the material other than what is stated in NACE MR075, or you have nickel content greater than 1%, something like that.
Yes.
So if you, then we need to go for, or you have a hardness, weld hardness, you cannot reduce 22 HRC, then you test the material and then qualify that hardness, whatever hardness you are getting. Like suppose you are getting 25 HRC, 28 HRC, or to go greater than 250 HV in case of welds. Suppose you are getting higher and normally your PWST is not bringing down the hardness, then you do the SSC testing so that you qualify that hardness.
Okay. So
Basically a qualification testing.
Generally I think SSC is very costly and rare, right, sir? I think we don't get the material with that generally.
No, SSC testing is like you have to go for 30 days and you have to, it will be like around 2 lakhs around the testing, costly only.
Yeah.
So, and generally we try to avoid, generally.
Yes. Yes. Yeah, same thing. I mean, based on discussion we had last week, the same thing I explained him, so he agreed. Thank you, sir, for your guidance. Yes. Yeah.
Most welcome.
Yeah. That's all, sir.
Okay. So means SS material we don't require any HSC testing, right?
Generally not required SSC testing. So that's what we.
Okay.
No, SSC testing will be done for SS material also. It is only HIC we don't do for SS material. SSC testing, they will go for this one. They have their own, the testing, qualification testing is given in NACE MR075. But you qualify only when you go beyond certain parameters, which is given in NACE MR075. When you MR075, when you exceed those parameters, again you have to go for a qualification testing.
Okay. I think Ramesh, you got your
Yeah, I got it. Yeah.
Okay. Some new person, I think Leo Eddie. You are coming first time?
Yes, sir. This is my first time, sir.
Okay. Can you please introduce to a group so they will understand you better?
Myself, Leo Edwin Nicholas. I'm basically a design engineer. So we usually, I belong to a design part. So I'm just curious to know about the and the principles of how they handle the materials and how they do that. So that's why I've joined this group. So I hope this will be very useful for me to work on. So this is what for myself.
Okay. Total how many years experience you have?
Sorry, sir?
How many years of experience you have in designing?
In 10 years, sir.
10 years. Okay. In static equipments, right?
Yes, sir.
Okay. So you want to know something about material related something? Just to-
Yes, sir. Yes, sir. Yes, sir. I'm just observing everything, sir. So whatever you people are discussing, so I'm just observing. So if something it strikes me, I'll just shoot out my questions, sir.
Okay. Okay. Normally in this group, whatever we faced in this week or maybe recently, we will discuss those issues. And if anybody knows the answer of those, so they will explain how they handle those situations or those
Yes,
issues.
sir. Yes, sir. Yes, sir.
Okay. Okay. So you currently don't have any issues to discuss, right?
Yes, sir. I don't have any issues, sir. I'm just listening, sir.
Okay. Okay. Any other? Neeraj Pandya? You are also coming.
Yes, good evening. Yeah.
Good evening.
No, I visit do regularly.
Yeah, you're
But,
after a long time you're coming, I think.
This time I just wanted because all experts are there.
Sir, I have a question, sir.
Yeah, tell me.
This is regarding the CRN, sir.
Mm-hmm.
So basically, like we'll be modeling pin coolers.
Mm-hmm.
So we'll be having the end cap look like elliptical head.
Mm-hmm.
So what is the concern is like, do we need to consider CRN for that or else? So I have read elliptical head doesn't have required any CRN, but since the fin cooler size is about 2 inches, so definitely it is considered as a fitting size. So does it CRN to be considered, or since it's elliptical shape, we should not consider it? So we have
What is CRN? What is CRN?
Canadian registration number, sir. For all the pressure equipments we used to provide.
Okay.
Canadian,
So
I
I
think.
don't have any idea regarding CRN, but I can help you. So what is the concern with the CRN? I mean, when it will be done?
Yes, sir. This is a certification, sir. So we need to perform a test, additional test, and also it will additional costs, sir. Actually.
Mm-hmm.
So
are you supplying this item loose?
No, sir. It's a complete assembly, sir.
Okay, with the vessel, right?
Yes. It's combined with the vessel, sir. It's not a single unit. Combined unit, including a vessel. We'll have piping spools as well as this cooler, sir.
Coolers, okay.
Yes. For cooler, we make it as a separate assembly. So that entire assembly, we need to give a CRN number. So these are the fittings we have been used. We need to submit those documents for the supplier of Canada, sir. If the equipment is supplied to the Canada, we need to provide the CRN certification, sir, for the equipment.
Okay, CRN certification, I understood it is given for an assembly. So then, how it is a concern for an individual part, individual component?
Yes, sir. There is a certain categories to be considered, sir. So for the forging fittings and all the piping fittings we have to give, and for the piping and all, there is not requirement to provide the CRN, sir. Since that elliptical head, the end cap, more convenient if I share an image, sir. So as of now, I don't have any image of the vessel or the cooler. So if possible, I will share, sir. On Monday, when I reach office, I will just share the drawings so that it will be easy for you to understand what is my question is.
Okay, yeah.
Yeah, actually, your bought out item, you are telling that you have to submit as a separate some additional requirement or additional number, right?
Yes, sir. Yes, sir.
So, but this is not a bought out item, no? This is just your manufactured in-house, right?
Yes, sir. It's if the elliptical head to be fabricated, it should be a bigger size, right, sir?
Yeah, bigger, but even it's bigger or smaller, but it's done in your shop, no? It's not bought out, it's right?
Yes, sir. We are buying that from outside.
Yeah, if you are buying as a bought out, then you have to provide. I mean, as I came to know, you are providing bought out items as a different certificate, and what manufactured it's as a different certificate. Means different codes in that one in the assembly.
Sir.
So this is if you if you make as a
Leo, I have one counter question to you. See,
yes, sir.
You're concerned about the fitting, so welded fitting. So there will for nozzles, there will be nozzles. It is a pipe. It is also piping component, right?
Yes, sir. Yes, sir.
Yes, so why there is no concern?
Yes, sir. Actually, for in the CRN document, we just reviewed that. So they have,
Same, no?
yes, sir. For
Same,
the
no? So
extension, yes, sir.
how
For the extension
it's a
also they
pipe.
give.
It is also like a piping component.
Yeah,
It is
if you make it as a
quite
bout
flat.
out, then it is a different item. If you manufacture, then it's a different certificate, right? In as per their code requirement,
Yeah.
right, Leo?
So I mean, as far as I see, it should not be any problem because it is directly welded to the. I mean, it's a part of the vessel, so there should not be any problem. But anyway, since we are not expert, I think
Yeah.
you better.
I think Neeraj
Yeah.
Pandya, did you done anything something like this? Anshul, you want to say something?
Leo,
Yes, sir.
can you, no need for sir, huh? Can you please send me this query? I know a person who has done multiple CRN jobs and I would be able to give you the answer later.
Sure, sir.
But,
Sure, 100%.
sir, even in the piping category, piping is exempted in the CRN, but when we have exchangers that utilize piping, certification for them we have to provide.
Yes, yes. Okay.
So certification you have to provide, but it's a different category. As Leo said, it's some different category, right, Leo? Piping
Yes,
different category, water different category, and in-house manufactured is different category.
Hello.
Yeah, Neeraj, tell me.
Yes, we have recently executed this Canadian CRN registration for air product. And this Canadian registration, as just now I think somebody has asked about the piping and fitting. So if you open that CSA B51 code, there is a first section they are providing for the equipment, and the next section is for the fitting only. So I just wanted to know there where it is written that elliptical doesn't require CRN, because we have supplied all the equipments having elliptical descents, and it's having also some piping components, walls. So we have got registered through EPSA, and we got all registration number, and the rest are under fabrication and final fabrication.
Okay, so Leo, just Neeraj is asking where it's mentioned in that elliptical is not applicable.
As sir, actually, it was not mentioned anywhere. Like when I was discussing with our engineers, like they were advising us to not to consider for this part while we are making bill of material for the assembly, entire assembly. So it was a question raised from the engineer side. Why you didn't consider for this kind of why you did consider for this part? So my explanation was that
Your
since
scope
it's
is your scope is equipment supply or piping component supply.
equipment supply only, sir. But
It's
it's
a
a part,
package.
sir. Yes, it's a package, the entire package, sir. We make as a sub-assembly.
Correct.
3D models, bill of material should be in the subcategories. So that question was raised from the engineer, so I was not able to give a clear answer to him, and also he was also not aware, but we were in confusion state.
No, I am very clear that yes, I am very clear that this kind of exclusion is not given in CSA B51.9 and .19. I am very clear because we have recently executed this one. And yes, they have arranged this PE signing and authorization of all drawing, because whatever design we are doing as per SME only, and then you have to re-rate by MAWP and submit them for approval. And after getting that approval of the dossier, you can start fabrication. That is what the procedure for CRN. And I have not come across such kind of exclusion. So, and I'll also check, because we have supplied all the equipments, pressure vessel and piping component and valves. But let me check. But I am very sure that that kind of exclusion is not there.
Okay, sir.
Okay, meanwhile you can share on Monday whatever you will
Sure,
get.
sir,
So
definitely, sir, I will share, sir.
but as per Neeraj saying, it's not there, not excluded, so it will be in all therein.
Yes.
Okay, Leo, you got your answer?
Yes, sir.
Okay.
Thank you very much, sir. Thank you.
Welcome. Any more? Okay, any other? So in this welding and that one, how the welding rods and that one to be considered for this different, means if different metals we are joining, like if we want to join with SS with CS, so how the welding rods and that one to be selected in that one?
So basically, this is more established actually. What we see is basically matching filler wire is the first concept. Second concept is the two different materials when you are welding. You have to consider the thermal coefficient of expansion in order for that to not to crack. And then third one is the property what you require for the weld joint. Like suppose you are having a corrosion resistant metal. So you are joining a two dissimilar corrosion resistant metal. So then you have to have a filler of metal which is more resistant than both of that. It is usually practiced that way. Otherwise, then you will use the filler wire which is those two combination which is having higher corrosion resistance. You use that filler wire. So basically, the thermal coefficient of expansion we need to consider. Okay. So that is the main criteria in dissimilar filler material selection. And then when there is a corrosion resistance required, then you need a bit of additional consideration. Like you have to select a filler material which is more corrosion resistant than the two materials which is joined, or select a filler wire which is having the highest corrosion resistance in those two couple.
Okay. So continuing this one, there's some means if when we join with this CS and SS material, so how the corrosion, how to consider that one, which to as you said.
No, basically when CS is involved, you don't have much of a corrosion resistant application. It will be like basically you have because CS is not corrosion resistant. So most of the corrosion resistant application, when you are joining CS to SS, then you directly go for 309 LMO, like directly welded. Otherwise, what we do is to compensate for the thermal coefficient of expansion, we will go for buttering. Like on the CS side, you will have another material which is superior, and then that is compatible with the SS, and then you will weld the that buttered layer to the SS material. But in case of CS to SS, we directly weld with SS 309 and LMO. And then in case of other materials, like we will have a buttering layer, like P3 to P4 when we are welding, we will generally, if there is a PWST difference, then we will go for, like a buttering layer and then do two different temperature PWST. There are many criteria. And more it is established. If you can tell me a specific combination, we can discuss. Like,
actually in our group, they specified there is a skirt. And that skirt is joining means it's two parts they made, means top part it's with SS, they are joined with SS skirt, means half part is joined with SS, and below is there is another part which is CS, and this is SS is joining with CS, and bottom is at CS metal and top is SS metal. So these two are they are joining. So whether it's compatible or whether it's
let me understand. The pressure part is SS and the skirt is CS or SS. Let me understand it. Sorry.
Yes, skirt is half is SS and half is CS.
Half is SS and half is CS. So the skirt is CS, right?
CS is half means it's 2000 if the length of that skirt, 1000 is with SS and 1000 with CS. The top part which is connected to vessel which is SS, and bottom part which is connected to bottom.
In this case, what I can see is they have avoided the dissimilar metal combination with the pressure part. So pressure part to pressure part, non-pressure part, the first skirt, they have welded made as the same material and then welded with SS matching filler wire. And then for strength purpose, the remaining bottom one non-pressure part to non-pressure part, that is SS skirt to CS skirt, they have welded with 309 LMO.
So in this case, what the corrosion and that one we have to consider in calculation or any design and that one?
No, here this is only exposed to atmospheric corrosion. So basically you don't means if it is on a very corrosive environment like offshore in mid of the sea, then you need to coat it, then you need to go for a painting. If you are putting it in an onshore or in a desert environment or something like a not a arid environment, not a very aggressive environment, then you can leave it as such. So it depends upon the client requirement also. Some clients even they say that wherever you see SS you paint it. Some clients say that paint only when it is in offshore or in the onshore no need to paint. So like that. No, so there is no major issue with respect to corrosion. Only the atmospheric corrosion is the only damage mechanism. So we will just avoid by painting itself. That's it.
Yeah, but in client specification they mentioned CS parts is 3 mm corrosion and SS part nil. So which to be considered?
Even for skirt, structural member they have mentioned like that.
Yeah, skirt they mentioned 1.5 corrosion allowance for CS.
Okay. So basically, they have given a very conservative approach, but okay. 1.5 is the minimum corrosion allowance we give because there will be a rusting or something like that. So that will also occur over time. So you will have a loss in thickness. So that is to account for that they are given minimum 1.5. But generally, what we do is we will go for a painting.
Okay.
Okay.
Painting we will do on the CS part, right?
No, CS also, SS also. Like in India, this is not a common culture. SS they leave it as it is. But in foreign countries, generally the CS and SS both are painted.
Yeah, painted with different thing, different this one, no? SS
No, you can go for. Only thing is that for CS we have to use like a. No. We can use a. See, the problem is they don't want to use zinc primer in SS. So they will go for epoxy primer in CS and SS and epoxy top coat and polyurethane top coat. So we can use that one.
Okay.
Epoxy primer, epoxy top coat, polyurethane top coat. Epoxy mid coat, polyurethane top coat.
Okay.
Something around 250 to 300 microns, more than enough.
Okay. So in India, as you're saying, just they will leave it as a doing some passivation and that one activity, just cleaning, and that one they'll do on CS metal, and they'll not paint anything on SS part, right?
Yeah. Basically, India still, they think that, SS is totally resistant, but it is not so.
Okay. Anybody? Anything? Any other? I think today is your day, so fully we have discussed on material related issues today.
Yeah.
So you are telling that.
Sir, thank you so much for your in-depth explanation of the mechanism of the SOUT, HS and SSC and SCC. Yeah, thank you so much, sir.
Thank you, Vishwanathan. And
My pleasure. I have never been there, but I had a chat with. I don't know his name. His
Ravi.
name comes Sri Asante.
Yeah, Ravi, you can.
Yeah, then he.
Yeah.
Thank you, Vishwanathan. Yeah.
Actually, Vishwanathan telling that I am not contributing anything in this group. So he telling that I want to leave the group. I told that there are many queries asking for material related, but you are not joining the meeting or you're not answering. So today he joined, and you full day is today completely discussion on material. Okay. Thanks for that joining the.
Now, when next time when we see our perspective will be completely different.
Yeah.
Yes.
So Vishwanath, next time you have to keep your some slides and that one ready so that you can share the queries raised in the material related.
Yeah. I will be prepared.
Okay. Thank you.
Thank you, Vishwanathan.
Okay, sir. Thank you, sir. Yeah.
Thank you, Vishwanathan, sir. You have contributed a lot today in today's discussion. It was quite elaborative and giving much insight on this, especially on the stress corrosion cracking and HIC. It's really good. It is really refreshing ourselves.
Yeah. We are not going that depth in the material and that one. No, we are static. We are looking on our field only. So
Thank you, Vishwanathan, sir.
Yeah, thank you.
Abhayji, thank you so much. You are very kind. Giving a lot of things. My pleasure. And I would request that suppose you have any query and material related query, you can put it in the group. And suppose if I am not seeing or responding, kindly put it on my personal number. Definitely I will respond. Once it comes into my personal number, I answer all my messages. So probably sometimes the group messages I may not see, I miss. But if I'm not responding, please put it in the personal message. So I will respond.
Yeah. We will also take care. Whatever if material comes, I will forward to you then. Okay.
Yeah, please.
Okay.
And Abhayji, anyway, we can chat in our company teams.
Yeah, you are in the same team, same group.
Yeah, we are sailing in the same boat. So thank you, Vishwanathan, sir. Yeah, really, thank you very much, sir.
Okay, can we wind up? So
Yes, sir.
okay.
Yeah.
Okay.
Thank you so much.
Thank you.
Siddharth, sir. I will thanks to Siddharth, sir. That Siddharth, sir, has introduced to this forum. So I'm thankful to Siddharth, sir.
Yeah, Siddharth also last time he came and he introduced. Then he came to know that it's something useful, so he added you in the group.
Thank you very much. Thank you.
Okay.
Okay. Bye.
Bye. Thank you very much.
Yeah. Thank
Thanks,
you.
Siddharth.
Thank you.
Bye. Thanks.
Good day.
Bye. Thanks.